Hey guys, just a quick note before we get into the following video. If you're already familiar with Arduino and, we're not going to review their entire product line, but Arduino and sites where you like to purchase them and information on them, then there's no need to watch this video. We're not going to get into the technical aspects until the next video. The next video we're actually going to start programming stuff. So I just wanted to give you a heads up because it's a long video. It's an hour, and we go through sites and we can purchase sensors and all that other stuff. And if you're not interested in that, I don't want to waste an hour of your time. But the next video is where we will actually install the Arduino software, and we will build our first project, our first small Arduino project. We're going to do the nightlight just so you can see how that photocell can function as a sensor. Anyways, on with the video. Hello everyone. Welcome. And today is going to be our first, well, it's really not a tutorial or a lesson on microcontrollers. Basically, we're going to do an overview first. We are going to install the software, which is very easy to do because other than the drivers for the board, it's basically a portable app, just like processing is. Processing is a programming language that I use. It works well with my electronics, and Arduino is actually an offshoot of that. Okay, well, let's get to it. Microcontrollers. Now, there's no real syllabus for tutorials, and there's still a lot to learn with electronics. We still have to go over voltage dividers, gates, op amps. I mean, there's a lot of stuff, and actually the next electronics I'm probably going to do is decimal, hexadecimal, and binary conversions, which are very easy to do, so don't be intimidated by that. But anyways, so since usually you complete course in electronics and go into microcontrollers. Since these there is no syllabus, and there's not even a script. I think I'd like to keep it interesting by using, and I don't think it's going to interfere with the education at all, actually you'll learn more. You'll learn that LDR that we did in the nightlight was actually kind of a pull-down resistor in a way, and that's what we're going to use for a pull-down resistor in some of our sensors for the microcontroller. But anyways, as far as the microcontroller is concerned, we're going to do that in parallel. We'll do maybe a microcontroller and we'll do a microcontroller tutorial, and then we'll do a electronics tutorial. I haven't really decided how we're going to do that yet, but I'm going to keep producing these and correct any mistakes or any if I did something in a wrong order, I'll correct that as well. And of course, I rely on your input too. If you see something that's wrong, let me know. Constructive criticism in a positive manner can only increase the value of these tutorials. So basically, this is not the microcontroller we're working with. This is a Chumby Hacker board. This is Adafruit Industries. Let me select Arduino. Arduino is the microcontroller I am going to use for my tutorials. There are many microcontrollers out there. Parallax has Basic Stamp and Pickaxe, and they all get their proprietary languages with them, whether it's BASIC or what have you. But Arduino is an open source hardware solution for microcontrollers, and it keeps the expense down. I don't know if you're looking at this $65 right here, but don't sweat it. We can build these things for actually less than $10. There are many. Arduino comes in many flavors, and we're going to see a few of them today. And but I'm going to recommend one particular flavor. That's this one right here, the Arduino Uno. I actually don't have any of these. I have the Demulev, which is identical. It's just, this is the new model. They did a few things to the board. But For all intents and purposes, it's not going to make a difference in the tutorials or anything else we do, programming. But this is going to be my recommendation for now. Actually, and the reason why, let me get into why I'm recommending this first. Then we'll go over the kit. Then we'll download the code. Okay, the reason why I'm recommending this is because when you're first starting out in electronics, and especially with microcontrollers, there's a lot of things you're going to want to do. And I found that if you get some gratification in being able to do some of these things sooner rather than later, it can help keep you interested in I don't want to call it the field, but because many of you have it as a hobby. Some people have it as a profession. I'm a network engineer, so I do electronics as a fun hobby myself. But it keeps you interested, and you can do some amazing things very quickly with this particular one. Now, throughout these tutorials, you're going to learn how to do all the stuff I'm about to discuss with you the hard way. And it's not even really the hard way. But anyways, the reason why I recommend this is because there's something called shields for it. What happens with this microcontroller, let's see if we got another view here. Here's another view. See, these are all holes that connect to the different digital analog pins, power, and stuff like that. So what Adafruit has done, and what many of others have done too, Adafruit's just one of my preferred sites. I don't even get a discount here, so it has nothing to do with that. It's just my personal preference. Please feel free to buy these from anywhere you'd like. There's many sources for them. We're going to go to Maker Shed. We're going to go to SparkFun Electronics. The only reason I mention it, and you'll see why, one of the reasons I like this site. So there's these things called shields. And what these shields do is they mount to the top of this microcontroller. Now, what is a shield? Well, there are many different kinds of shields. Let's say you want to easily control a bunch of motors. You want to create a robot. So they have, Adafruit has a stepper motor servo shield for Arduino. And so what happens is you create this kit, and I don't know if you can see the Arduino right underneath here, but she sends, this goes out, by the way, you will get a lot of practice in soldering, because this goes out disassembled. And so you will create this, you'll put it on top of the shield, and she provides example code. Actually, let's go through this a little. So here's the shield itself. And you'll actually build these. I have a couple of these motor shields because some of my smaller projects, these won't work for big motors. I'm not sure what the rating is. I think it's 1.6 amps for these integrated circuits. And we're actually going to build motors without all this. Build motor controllers without all this eventually. But this is nice for small projects. And it can be done quickly. So this is the shield itself. So let's say we purchase the shield from Adafruit. Well, then we would come back here and we'd go to instructions, examples, and other documentation. Okay, so here's our motor shield. And you'll notice over on the left here we have overview, FAQ, make it, use it, download it. There are some things under this as well. This is the overview. It tells you about it. 2 connections for 5-volt hobby servos, 4 bidirectional DC motors, 2 stepper motors, and we're going to go over all, not today, but we're going to go over what these motors, what the differences between these motors are. And this is a DC motor, this is a servo, and this is a stepper motor. A stepper motor is basically used for more precise control. I'm building a laser etcher that I'm using stepper motors for. So this tells you, gives you a little bit of the background of the kit, and it says 4.5 to 36 volts. Pull down resistors. You'll be learning what those are. Keep the motors disabled during power up. Oh, okay. So it wasn't 1.6 amps. It's 0.6 amps per bridge, and 1.2 amp peak. That doesn't mean I can run it at 1.2 amps forever. No. And there's actually a way to take another chip. She might even explain it in here. And solder it on top of these existing chips. And so that you can actually double that and get, 1.2 amps per bridge. Anyways, we'll actually build one of these shields, and we'll go over all of this. So that's the overview. The FAQ is just a question and answer. She has these for almost all of them. Make it. Okay, you have the tools that you'll need, of course. And it's good to research this stuff before you actually pull the trigger and buy it, so you know what you're getting into. So when that package comes and you're so excited because you want to put it together, and you realize, oh man, I need a soldering iron, or whatever it is you need. It's good. I found that the more preparation you do, the more fun you'll have when you actually receive it. Another reason why I like Adafruit is if you don't want to buy her kit, let's say you think, well, that kit's too expensive. I could get all those pieces elsewhere a lot cheaper. Well, yes, you can. And not only does she provide you what the pieces are, but she actually provides you links to places where you can buy the pieces cheaper if you wanted to a distributor. See, you can buy them here, or if you wanted to buy the extra ones to put it on. But you're not saving so much money that I think it's worth. One, I don't think it's worth it. Two, although these kits are more educational than I found for most of like the Ramsey kits and stuff like that. She doesn't. It's not a class in electronics, but it gives you all the pieces in one place. And if there's an issue with one, you have one source to go back to. And remember what I said. I think I've received orders from her where items have been missing and then they sent them to me. But I don't think I've ever received a kit where a part hasn't worked. So if it doesn't work, make sure you triple check everything. Because it's usually us. Because I've had parts that didn't work and I took my time and took a deep breath and found where my issue was. You want to make sure you do that too. Okay, another great thing about this site is the soldering. So here's all your components. She takes you through step by step. And like I said, although it's not a course in electronics, she does mention sometimes what these devices, she mentions what they are. And sometimes she mentions what they're there for as well. Not always, but like I said, this is to help you put it together, not to give you a course in electronics. That's one of the things I'm trying to do. Okay. Then we get it together, we solder the whole thing, and it's wonderful. It's all built right down here. You're probably getting sick from this video. It's all put together. How wonderful. Now what do we do? Well, then, of course, we go to the next step to use it. And she talks about all kinds of drivers. Don't get scared off by this. You really don't need most of this stuff. Especially when you're just learning. Get it up and running and understand it first, and then try to get into the schematics. But she takes you through, and she gives you example code. So you grab this code right here, and you copy-paste it into the Arduino IDE, into the programming interface. And you work with it. It's a great source for learning as well. You start changing some of these things, and you see what they are. We're actually going to go through step-by-step programming a lot of things in Arduino. Okay, so we use it. Downloads. Well, you can download the schematic. If you want, you can go get these circuits printed yourself. I mean, she's completely open with her source, her hardware. I found Adafruit to be a great resource for a lot of stuff, and I'm very happy with the quality of her products, and anyways, and what she provides you to actually do the things you need to do. So there's resources, Wikipedia, making things, tutorial on steppers. She like me lists all these other resources. I don't know what her point of view is or why she does that. I do it because I want to make this as easy as possible for everybody else. I'm not looking for anything for myself, but there's tons of resources, and I point out what I feel is good ones when I see them, and she points them out as well. Of course, you could buy the kit, and then you got forums. If you're having some issues, you can go to the forums and starter pack, Arduino. Arduino shields. And, you know, if you're having an issue with something, you have these forums where people can discuss things. Okay, so that's one of the reasons. Let's go back to Arduino. So that's one of the reasons that I recommend this first, because those shields that you see will connect directly to this. Not the Mega. This is a lot larger one. This has 54 digital I/O pins. This is for bigger projects. And I'm not talking about projects where you want to control a lot of LEDs, because we'll be able to take a smaller microcontroller and we'll learn how to use shift registers, and you'll control all the LEDs you want to from very few digital pins. So you don't have to go out and buy one of these Megas to control 54 LEDs. A lot of our beginning projects we're going to be doing LEDs, but that's only because, like I said in an earlier tutorial, it's a great physical feedback to what you're actually doing and seeing your code. Okay, so I recommend this, but if you can afford it, now this is $30. We're going to go to Maker Shed and Spark Fun. You'll see other ones as well. If you can afford it, let's see, where are it should be in here. Actually, I think it was just there. This right here, the Experimenter's Kit. This is a very, very, very good kit from Lady Ada. It comes with a breadboard. It comes with an Arduino. It says Demouliv. It'll probably come with an Uno. It doesn't make a difference. They both got the 328 18 mega chips. It's the AVRs. Don't worry about it. But in here, what do we got? We got wires, we got a battery connector, we got a servo, we got a DC motor, we got some pins, we have some resistors, screws, LEDs, some more pins, some switches. We got an IC. I don't know what that is, what that particular integrated circuit's for. Ooh, this is nice. We're going to be using these. This is a relay. You can, with very little power, you can control, like we're going to be controlling some AC devices from this little guy. It looks like you've got some PNPs and NPNs, piezo buzzer, some diodes here, capacitor. Oh, this guy here, you're going to need this guy too to connect. So if you went back and bought that $30 Arduino, you're still going to need a USB cable to connect him to your computer, because that's how you program. You connect him to the computer, and then you upload your program here. Now, what is the microcontroller on this board? Oh, actually, before we get into that, I highly recommend this kit. And let's see, the little guide it comes with is online. We bought a few of them for the robotics club, and you know, they get lost or stolen, and it's great because she actually has this online, so the students can now refer back to this. And this, one of the reasons I recommend this guide, not only does it tell you how step by step how to install the software, which is not very difficult for the Arduino interface, but it takes you step by step through many projects. LEDs, it does motors, so you can get a good understanding how to control a lot of devices with the microcontroller without the shields, because this is without the shields. Actually, it comes with, you'll see here, it comes with these paper diagrams you put down, and you can actually plug things through. Let's see. So there's lots of neat little projects in here, and you'll learn a lot from this. And this is something you don't have to wait for my videos for. You know, you'll get this, and you can start working on this on a regular basis. I wonder what this circuit's for, because I notice it's using the relay. Yeah, we're going to go through relays, and we're going to go through all this stuff. But so anyways, I highly recommend this kit. It's a great kit. Like I said, we're going to do so many. We'll even do some of the things from this kit on our videos, but it'll give you the opportunity to learn some stuff in between the videos. Okay, now let's go to sensors. We'll get to the other stuff in a minute. Let's go to sensors. Now she has a lot of sensors. We're actually, okay, now this is a joystick here. We're actually gonna, I'm starting a second set of tutorials on processing, which is a programming language. And you can interface with your electronics and your microcontroller with this programming language. And I'm using it to write games, and I'm going to have a series on games, and we're actually going to build our own controllers for it. So I'm going to show people how to program games in processing, and if you want to get a head start, just go to www.processing.org. And that is open source software. You just download it. There's tutorials and everything there. Get a move on if you want. But we're actually going to, it's got the same IDE, the same interface as Arduino. They're I guess you could say they're mated. Okay, so anyway, there's lots of things. This joystick is considered a sensor, and you'll see why. There's 3-axis accelerometers, all kinds of things we're going to do. This is a neodymium magnet, high strength rare earth magnet, that if you use a Hall effect sensor, I think she's got Hall effect sensors, temperature sensors. So there's all these kinds of sensors. This is a temperature sensor. We're going to work with a lot of these sensors. A lot of them are very easy to work with. Once you learn 1 or 2 of these, you'll be able to use a lot of them. This is an IR sensor. We'll use these ones. I prefer the ones from SparkFun. This one has a wider beam and a shorter distance than the other one that I like. But anyways, so there's lots to explore on this, and I could wind up spending a lot of money here. GPS modules. We actually created a GPS project here at the university where we put GPSs on the buses, and we could track them going around the campus on maps, which was pretty incredible. I'll probably show you guys that as well. Okay, so there's lots of things here to go through. You can go through, with the robotics. The motor shield kit. Once you get that and a couple of motors, you can pretty much build a small robot if you want. Servo wheels, stuff like that. There's a lot of good sites. There's a robot site I like too. I'm not going to show you today. That's for a later day. We're already running late on this one. Okay, let's go over to SparkFun. Now, here is that Arduino we talked about, and it's the one I recommend you initially use. Well, and I told you, because of the shields, and you can do a lot very quickly with it, very easily. The one I usually use is a lot smaller. Right here. And of course, you need an, let me go back here. Adafruit. Sorry if I'm making you sick with the scrolling, but I need to find the FIDI cable. Because although you're going to use a USB cable for this, there are many things you're going to use a FIDI cable for. So let me see. It should be under accessories. No. Is there a cables? Sensors, tools, wires, cables, etc. Of course, it's near the end. This cable right here. This cable is going to come in very handy, especially when we start programming our wireless stuff, because we're going to do wireless stuff. And I'm not talking about 802.11b GN, which we can do that easily enough. But I'm talking about our own wireless communication over like 900 megahertz. Actually, before I show this, let me just do that. This is the one I use. It's tiny. It's teensy. Let's see. There's one with a quarter. See how small this is? I'm actually going to show you a video of this. I'm going to show you a couple of things in my office and some of the projects we'll be doing in the future. But this is the one I use. But there's no shields for it. Everything you build, you have to build for it, which is not very difficult to do. You just need to understand how it works, and you can build for it. But to use this one, there's no USB interface. I've got to use a FIDI cable. You see this black green here? If I come back over to Adafruit, there's a green and a black wire here. That's how I know how to align this up. And these are programming exports, GPS, XBs, all kinds of stuff. And now that I showed you so there's all kinds of flavors of these Arduinos. And once you know how to program one, you can program all of them. They pretty much program the same. They just have different amounts of memory, and you choose a different one from the drop-down menu in the IDE, the Arduino IDE. So let me go back one here. And we'll see many different Arduinos. Pro, Mini. This is 3.3 volt. I use the 5 volt, 16 megahertz. We're actually going to build a 5 volt, so we could take any voltage and bring it down to 5 volts, almost any voltage, and bring it down to 5 volts for our projects. So I'm actually going to use a 5 volt. They come in 3.3 volt as well. This is a lily pad. Now this is, a lot of craftspeople use this, and you can get actually thread, conductive thread, and they use this a lot in making light up designs and fabrics and stuff in clothing, because you can sew this conductive thread right in there. So if you want to do some kind of cool t-shirt or something that lit up, you could use one of these. And so they come in many different flavors. Once you figure out one or two of them, you can pretty much figure them all out. Once again, this uses to connect to it. This is the same thing. This is like the FIDI cable. You connect your USB in here, and then the FIDI communicates here. So you don't have to do the cable. You could actually do one of these and plug it into USB, and then plug in the prongs if you wanted to do it that way too. I have a couple of FIDI cables. I have a couple of these. It depends on what I'm working with. And I know this overview is getting long, but I think it's important that you get an overview of this microcontroller, or these series of microcontrollers that we're going to be using. So when you start to do your own projects, you understand that there's more than just the one that we're using out there. And you can actually choose things to suit your actual project. Now, we have a LilyPad tutorial, set up, install software, introduction to Arduino. So most of these sites are pretty good about sharing information. You know, schematics, you got the data sheet. This is actually for the microcontroller chip. That's another thing I wanted to mention. Let's go back here. The microcontroller. What is the microcontroller? Actually, let's do it from Lady Ada, since she sells the chips by themselves. Let's see. Okay. This chip here is your microcontroller. You don't really need anything else except for, let me zoom in on that. Basically, take this chip out, program it, put it into one of the proto boards I showed you with a couple of items. We'll actually go over that. We'll go over what all these pins equate to. See, we have 0, 1. These are digital pins, 0 through 13. We're going to take this step by step, so don't worry about getting it all down now. And these are analog pins, 0 through 5, which is 6 analog pins. 0 and 1 are actually the transmit and receive for the chip, so you can communicate with other things. Oh, wait a minute. This might be the... Why did I think that? Anyways, so basically you'll only need a few items to go with this, and this is the controller. So you can actually buy one of these boards, and then let's go to accessories. Okay, let's go to Arduino. Oh, by the way, they sell these pins and stuff too. That makes it easy to connect things to your Arduino, or to connect other items that you can plug right into it. And okay, I'm gonna have to do a search. Oh nope, there it is right here. She sells her own chips for $6. The 328 with her own bootloader, which I guess speeds things up a little, and, well, it doesn't speed up the processing, but speeds up the boot and allows more memory to be utilized for your code or your projects. So you can buy a few of these, get one of those boards and prototype it out, and then add the crystal clock and a few other components and implement it into a proto board if you want. You know, it's still going to cost you like $12 maybe for the whole thing, $10 to $12. I mean, it is cheaper than the $30 to use a whole Uno on every project. But there are, let's see, Arduinos. There are cheaper options. 17 bucks for a few bucks more. This is an Arduino clone. And this is pretty small. Not as small as the one I showed you from Spark Fun, but it's pretty small. And you can easily use this with a breadboard. Or not. I mean, this will actually go into a proto board too. It's got its own power supply, so, you know, you can hook up, and this looks like, I haven't dealt with these ones much, but this looks like it's either a 5 or a 3.3 volt regulator, so you could probably put, I'm guessing, at least 9 volts in here if you wanted to, and run it that way. Of course, you can look into Arduino web page. It's got the same thing here. So you can do your overview, your questions, and find out exactly what those 5 volt, 1 amp power regulator. So it was 5 volts. And of course, 2.1 millimeter barrel jack. But if you're curious, where can I get just 2.1 millimeter barrel jacks? Well, make it. DC parts list, USB parts list. I don't know which one it's under. Right here. Boom. I want a bunch of those. Come here and boom. Buy a bunch of them. Oh, wait a minute. Oh, DigiKey, she lists multiple sources. So you can even choose what source you want. Of course, they're all made in China, but isn't everything? Okay. So, yes, you could do the chips, and you can, and we will actually do that. We will take a chip, we will program it, and we will put it into a proto board, and we will use it. Just so, because you should have the understanding and you should have the experience of doing it. But for the most part, I myself will just spend the 18 bucks and just get one of these. Okay, so we dealt with the FIDI cable. You'll need a FIDI cable to program one of these. But one of the reasons I like Spark Fun is they have so many sensors, everything you can imagine. Triple axis, single axis, accelerometers, gyros, infrared. These are the ones I was talking about earlier. I think these are the ones, the short range ones, that either this one or this one was on the Adafruit site. These are the ones I use because it's really not that long a range. If you really want long range, you can go... No. Let's see. Proximity. You can go these guys. These guys will work up to like 25 feet. And the difference between these numbers are how narrow the beam is. Here, this is a lot narrower beam than this one. This one's an incredibly narrow beam, but this is a very nice one. This is for the sonic walking stick for the blind that I'm developing, and the videos for that will be posted as well. This is the one I'm using for that, just because I want a narrow beam. It's a 2-foot beam, approximately. And we're going to go over all this. We'll come back here and go through the data sheets and all that other stuff. But there's all these incredible sensors, and then Wi-Fi that I mentioned earlier. These guys, anywhere from $22.95. It says 40-mile range. Yeah, that's line of sight under lab conditions. You're not going to get 40 miles. We got 2 miles with just like one building in the way. But, you know, if you're out on the ocean or you do have a line of sight, another thing is you have to deal with the curvature of the Earth. So when I say line of sight, meaning the Earth can't be in your way either. On a high building, we've gotten 10, 20 miles out of these things. So all the way up to that, because you need 2 of them at $184. But some of these, I believe this one is like 300 feet. The Pro Series, I think they have, you know, you could put better antennas on it. And it's about double, but you get a mile out of it instead. And like I said, that's under ideal conditions. But for programming these guys, and actually let's go back to Adafruit, because in her store, she has shields for the XP too. So she has this shield that you can build for the XP. And of course you need a FIDI cable to program it. And then you can connect it right to your Arduino, and your Arduino can send stuff wirelessly. We're going to do all this. And I probably should be mentioning all this, because you're going to be like, oh, let's do it. I want to do it today. we're going to have to go step by step. The next video after this is going to be the Arduino itself and doing the sensor. Maybe I can even fit it into this one. I don't know. We'll see. I talk too much sometimes. Okay, so there's other places to get it to, like Maker Shed. I love SparkFun for the sensors. I always find a sensor I want. There's some robotics. There are better robot sites. Like I said, I'll show you that another time. Some brushless motors and stuff like that. We'll review all that stuff. But you can get started. Buy that Adafruit kit and get going. Okay. Anything else? Sensors. I think I covered every. Oh, how about the Arduino site? Okay, so you get your board. You get your Arduino board. That's a nice clock. I actually built that. It's very expensive, but beautiful clock. You get your Arduino board. Then what do? Well, you need a USB cable. Okay, I told you that. So you came prepared. You either bought the kit or you got the cable separately. You can get the cable right here. It's a specific cable. And let me make sure we get the right cable. See, they're like, this is a mini. You don't want the mini. This is the standard. This is the cable you need for the Uno right here. So let's say you got your USB cable. You've got your... Now what about the Arduino? Well, you need to plug it into the computer, but you need the software. So let's go to the open source Arduino software site. It's www.arduino.cc. Now, of course, you can buy your Arduino, and this is the new Arduino Uno with the 328 chip. Download the code. Getting started, learning, reference, hardware, FAQ. Lots of good stuff here, guys. Anytime you're going through the code, well, how do I do this? They have all the commands in here, all the functions. They give you examples of them. There's libraries. And, of course, we're going to go through all this stuff, too. Learning, hacking, links, foundations, examples. References should be libraries here. Libraries for Ethernet, for connecting the Arduino Ethernet shield, and SPI for communications with devices. Servo controlling motors. I mean, there's so much information here. But let's start at the beginning.